We'll do a couple more examples of solving partial differential equations using the product method. So here's the partial differential equation we solved in this example. Rewrite it with different notation using subscripts, so it's like this. Be able to go immediately to the separated variables version of it. So this u sub x will be x prime y, capital letters. U sub y will be x y prime, capital letters. Get used to that. Here we use the separated variables. We start using algebra to separate those functions. I'll divide both sides by big X, big Y. That will cancel these Y's here. Cancel these X's here. So I have these two functions. At this point, they are separated. So I can set them equal to the same constant. Leads me to two ordinary differential equations. This equation, and this equation. These are not differential equations that we have canned solutions for. They're not on our list on our formula sheet, but we can use the method of separation of variables for ordinary differential equations. You can see they're both the same equation. So once I solve one, I've solved the other. When we separate it for ordinary differential equations, well, first we'll rewrite this x prime as d big X, d little x. That's all we did in going from here to there. And by separating variables now, we mean get all the big X stuff on one side of the equal sign and all little x stuff on the other side. So by just a little bit of algebra, we go from here to there. So at this point, we've separated the variables for this ordinary differential equation. We can integrate both sides, and I get natural log of big X on the left, and this minus lambda natural log of little x on the right. And I need to put a constant of integration on one side or the other. I don't have to do it on both sides. By algebra, the log of minus lambda log x is the same as log x to the minus lambda. Then I can raise e to the both sides and get what big X is. So it's this, some constant times x to the minus lambda. Since y, the y equation is the totally same form as the x, it has a similar solution. So the total solution is the product of these two guys, which is that I can combine the constants into one. So here's the solution to that guy. Again, you could put this back up in this equation and verify that it is the solution. One more example in this recording. Here we've got a second partial with respect to each of the two variables. In this notation, it would be this. This thing would be u sub xy. And let's see if I rewrite it with the separated or the product method of the two variables. This would be x prime y prime, and u is just xy. So here it is with the product method notation. Do some algebra to separate the variables. I'll divide everything through by y, x, y prime. So here it will cancel the y primes and the y. I've just left x prime over x. And here it cancels the x's. I'm left with y over little y, big Y prime. I'll get all the y stuff on one side of the equation, x stuff on the other, and set them equal to the same constant. Again, I'll use minus lambda. And I'm using the minus sign because on this x equation, it leads to the familiar format of a solution we already have. That's the only reason I use the minus sign. You could have used the plus sign. As long as you're consistent, it'll still work out. So the equation for the x case is an ordinary differential equation we've already solved, and it has this known solution. Arbitrary constant e to the minus lambda x. For the y equation, it's not a differential equation that we have in our formula sheet, but we can use separation of variables for ordinary differential equations. Here's what it means. Then we use algebra to separate big Y stuff from the little y stuff. Let's see. Here it is. For some reason, I've put the 1 over lambda with the little y. So at this point here, we can integrate both sides. This will be natural log of big Y. This will be 1 over lambda natural log of little y. You have to include the constant of integration. You can rewrite this first term this way, and then we can raise e to both sides e to the whatever the side is. And finally, we have a solution for the big Y. Total solution is the product of the two individual solutions, this x solution, this y solution. Find the arbitrary constants, and there we go. There's our answer. We'll do a second order example in the next recording.